So in this video, I'm going to go through the questions that were requested between 11 and 20. The first one was number 11. Asked for the mass of sodium that reacts to produce 960 centimeters cubed of hydrogen gas. Because you're working at room temperature and pressure, you're not going to be using the ideal gas equation. You're just going to be using the number 24. They've given me the volume in centimeters cubed, so I've divided by 24,000 instead of just 24, which is the number I use for decimeters cubed, and I get 0.04 moles of hydrogen. So if I want to produce 0.04 moles of hydrogen, what mass of sodium do I need? Using my ratio, I've got a 1:2, so the number of moles of sodium is going to be 0.08, and if that's the number of moles that I need, I multiply that by the formula mass of sodium, and I get 1.84 grams as my starting mass of sodium. The next one, 13, this is a bit faffy. I thought I could come up with a quicker way, but ultimately it's just trial and error. So you've got compound X, you're reacting it with O2 because it's a complete combustion. If you look at all of the options that they've given you, it's just carbon, hydrogen and oxygen, which means your only products are going to be CO2 and H2O, and they're telling you 1 mole reacts with 8 moles. So I know I've got a 1:8 ratio. I initially tried to use these numbers to kind of like work out what it would be, but that was faffy. It's actually much quicker to just go trial and error, although unfortunately in this answer the case is D, so you get through all of them before you get to the right one. But essentially by just plugging each one of these into this equation, you know it's always going to be 8 O2s, and then balancing and see which one works. So that one doesn't end up balanced, that's not balanced, that's not balanced, but that is balanced. You got 16 oxygens on the left, and then you end up with 16 oxygens on the right, and the carbons and hydrogens are balanced, so I know that's the right equation. But just, yeah, trial and error for that one. Next one I was asked for was a 15, which is here. So it's a percentage yield question. You're told the mass of C6H5 phenylamine. You're told the mass of phenylamine that you started with, and you were asked about the percentage yield. So if you're given the mass, the first thing you're going to do is you're going to work out a number of moles. So it's 4.5 divided by 93, and you work out the number of moles of phenylamine that you've started with. You've got a 1:1 ratio. They give you the formula mass of the product. So if you do moles times formula mass, this is the mass of the product that you should get using your moles table. However, they tell you that you don't get that mass, you actually only get 3.25. So this is your theoretical yield, how much you should get based on the amount of the starting material. And then this here is the actual yield, the amount that you actually get when you do the reaction. And to get the percentage yield, it's the actual divided by theoretical times by 100, 49.75, which matches the answer for A, 49.8. The last one I was asked to do for this one was 17. So these questions come up and they can be a little bit confusing. All right, so you've got 1 molecule of a gas. So you'll notice here this answer is tiny, which is what we'd expect. If you've only got 1 molecule and you're getting the mass in grams, the number is tiny. So I've written that there. That's the mass of 1 molecule. And then I've multiplied this by Avogadro's constant. And the reason is that if I know the mass of 6.02 by 10 to the 23 molecules, which I get by just multiplying this number by Avogadro's constant, then this answer here, 16 grams, is the MR. Okay, so the mass of 1 mole of a molecule equals the formula mass of that molecule. And once I know the formula mass, I just come over here and see which one of these has a formula mass of 16, and the answer is CH4. So the answer is going to be A. Okay, so formula mass is the mass in grams of 1 mole of a substance. And if I times the mass of 1 molecule by Avogadro's constant, I'm working out the mass of 1 mole of that molecule, and that equals formula mass. And then once I know the formula mass, I just need to see which one has the correct formula mass. So that's all I was asked to do for this particular section.